In this video, I'm going to show how to generate the points for a parabola by using the definition of a parabola, and then I will also show that the equation for a parabola like this is y equal to 1 over 4p times x squared. So this is the definition of the parabola. So a parabola is the set of all points that are equal distant from a fixed straight line, which is called the directrix, and a fixed point, which is called the focus. So what this means is this: start with any straight line like this. So let's start with this line, y equal to -2. So pick any horizontal line. In this case, we picked a horizontal line y equal to -2, and this is called the directrix. And then next, pick the fixed point, and we'll call this fixed point the focus. And so the focus, it can be above this line, this directrix line, or it can be below the directrix line. So let's go ahead and pick the point 0, 2. So we can pick the point, any point that is above this line or any point that is below this line. And then next, what we want to do is come up with all points that are equal distant from the line to the point and the point. So for example, here are 5 points. So let's take this point, which is the point 6, x is 6, and y is 4.5. And we want to show that the distance from this point B to the focus is the same as point B to the directrix. So the focus is located at 0, 2, B is located at 6, 4.5. The directrix is the line y equal to -2. So the distance from here to here will be 6 minus 0 squared, 4.5 minus 2 squared, and we get 6.5. The distance from here, from point B to the x-axis, is 4.5. And the distance from the x-axis to the directrix is 2. And so the distance from here to here would be 6.5. And so what it means is that this distance and this segment, they are equal in length. And then the same thing for this segment. This is 6.5, the length of this segment. And then the length of this segment is also 6.5. The distance from here to here is 4. 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 And so that's what we want. We want all points such that the distance from the point to the focus is the same as the distance from the point to the directrix. And so, and then now look at this point right here. This is point V. We call this the vertex. The distance from V to F to the focus is 2. The distance from V to the directrix is also 2. And then here are the other points that also have distance to focus and distance to directrix, the same. And so all of these points, so we pick any point, so let's take this point. The distance from this point to the focus is the same as the distance from this point to the directrix. And now if we connect all these points together, then we have a parabola that opens up. And so once again, to generate the points with the parabola, first start with a directrix, any horizontal line. Next, pick a fixed point called the focus. So the focus could be above the line, the directrix, or it could be below the directrix. And then next, find all points that are equal distant from the directrix and the focus. And then connect all those points together. Then we get the parabola. And then now we will show that the equation of this parabola right here is y equal to 1 over 4p times x squared, where p is the distance from the vertex to the focus, or from the vertex to the directrix, meaning the distance from here to here is p, the distance from here to here is also p. So that's what p is. And so let xy be any point on the parabola. And so what it means is that the distance from this point to the focus is the same as the distance from the point to the directrix. The distance from the vertex, which is at 0, 0, to the focus, we call it p. And therefore, the focus is at the point 0, comma, p. And therefore, the distance from here to here, from the vertex to the directrix, is also p. Distance from the point xy to the focus is going to be x minus 0 squared y minus p squared, and then take the square root. This point is x, y, and therefore the distance from the point to the x-axis is y. This point has coordinates x, y. So the distance from here to here is y. And then the distance from here to here is p. And so the distance from here to here is p. And so the length of this segment will be y plus p. This segment, the length of this segment, is equal to the length of this segment. And so we have d1 is equal to d2, or y plus p is equal to this, which is x squared minus a plus y minus p squared. Square both sides, and then we get y squared plus 2py plus p squared equal to x squared plus y squared minus 2py plus p squared. The y square here, they will drop out, they're cancelled out. The p squared will cancel out. What's left is 2py equal to x squared minus 2py. And then we get 4py equal to x squared. Solve for y, then we get 1 over 4p times x squared. And this is the equation of this parabola. Once again, p is the distance from the vertex to the focus, or the distance from the vertex to the directrix. In this case, the vertex is located at 0, 0. But if the vertex is located at some point hk, then the equation for the parabola becomes y minus k equal to 1 over 4p times x minus k squared. This is our original example where we started with the directrix down here, and then the focus is above the directrix. But if we start with the directrix like this, and then pick the focus, a fixed point focus that's below the directrix, then the parabola opens down. And then we could also have the case where the directrix is vertical, and then we picked a focus that is to the right of the directrix, and then the parabola opens to the right. And then we could also have this situation where the directrix is vertical, and we pick the focus that's to the left of the directrix. Then in this case, the parabola opens to the left. And for the parabola that opens down, the equation will be y equal to negative 1 over 4p times x squared. Once again, p is the distance from the vertex to the focus, or the vertex to the directrix. And then for the type that opens to the right, then the equation of the parabola will be x equal to 1 over 4p times y squared. Again, the distance p is the distance from the vertex to the focus, or the distance from the vertex to the directrix. And the last type, for parabola that opens to the left side, the equation for the parabola will be x equal to negative 1 over 4p times y squared. And the vertex is located at 0, 0. And once again, if the vertex is not located at 0, let's say the vertex is at some point hk, then the equation will be x minus h, and then negative 1 over 4p times y minus k squared. And it will look like this. So once again, if the vertex is at 0, 0, then this is the equation. If the vertex is at some point hk, then the equation for this parabola will be x minus h equal to negative 1 over 4p times y minus k squared. And that's the end of the video.